All right, for homework 923, I'm going to have you check all your work against mine to make sure it looks exactly like I'm looking for, graphs included. And then I'm going to have you write down the 5 words to let me know that you listened. Math 1, just turn this work in tomorrow. Math 1 honors, document this work on your slides. Make sure you're documenting the classwork we did today too in my honors classes, classwork 923. But again, copy all this work or check the work that you've done already to make sure it matches mine. Write down the 5 words. Paste this to your slides. Math 1, turn it in. Math 1 honors, make sure you're also documenting classwork from today. So here we go. First problem. You need to read these and see if they're arithmetic or geometric. This one is adding pennies. So again, on the bottom, I want to see that your table has days, and on the top, number of pennies. So again, on this, I'm going to go 0, 1, 2, 3, 4, 5 on the x-axis down here. And on the y-axis, looks like she starts with 5 pennies. So that's going to be my y-intercept, 0, 5. And she's adding 3 pennies every day. So plus 3 is being added each day, which makes this a discrete situation. Plus 3 gives me 8. Plus 3 gives me 11. Plus 3 more, 14, 17, 20. The equation, I could write f of x equals 3x plus 5, but since this is a discrete pattern, we're going to write it as f of n, using n instead of x, equals f of n minus 1 plus 3. Again, because she's waiting every day to get money from her father, that makes this discrete. Or Savannah's older brother, I guess I should say. All right, the first word is dot. Dot. All right, I do want you to graph this. So days on the x-axis, on the y-axis, number of pennies, using the scale 1 through 15, 1 through 15. 0, 5 right here. 1, 8. 2, 11. 3, 14. These are just plain dots. You would not draw a line through this. These are discrete. This is a discrete pattern. There's my recursive form. All right, next problem down. This one right here is a problem where you're filling a pool with water and you're starting to measure stuff when there's 5 gallons in the pool. So for this one, on the x column, we're going to do time in minutes. We're going to use t for the variable here. And in the y column, it's going to be number of gallons. So in time, we're going to go 0, 1, 2, 3, 4, 5. The 0 term, she starts with 5 gallons. That's going to be my 0 term. So 5 right here. And then I am adding 2 gallons every minute. Plus 2, that's my common difference. Plus 2, plus 2. So it's going to be 7. Plus 2 gives me 9. Plus 2 gives me 11. Plus 2, 13. Plus 2, 15. Because this is a situation where the hose is continuously pouring into the pool, we're going to use the explicit function using t. So f of t equals the common difference number 2 times t plus the 0 term 5. Or I could also use f of t equals 2 times t minus 1 and shift over plus 7. Either one of those. This is definitely explicit. Will be a line with the dots with a line drawn through them. This is continuous. The water is continuously pouring into the pool, not having to wait for the pennies like that last problem. And then if I graph it, time on the x-axis and number of gallons on the y-axis will be 0.5 for my first point, 1.7, 2.9, 3.11, 4.13, 5.15. I'm going to draw a line straight through those because this is continuous, explicit. All right, there we go. The second word is recursive. Recursive is the second word. All right, third problem is one that's geometric. And again, I could tell because any of these percent interest problems timesing geometric. So for this one, on the bottom for my time, it's going to be in months. Top is going to be dollars. We're going to start with 0, 1, 2, 3, 4, 5. Or 0 through 4. The zero term is that $50 that she's starting with in her account. So 50 will go right here. And then this is one of those interest problems. So I'm timesing by this interest rate added to 1. So 1.03. 50 times 1.03, which gives me 51.5. Then I take that 51.5 times 1.03, which gives me 5301 rounded, and then that number times 1.03 gives me 5460, and then that times 1.03 gives me 5624. All right, this is a continuous problem. I'm going to write the explicit form. The money is constantly making money while it's in that account for a month. So the explicit form, of course, for these geometrics is f of, and there you have me use m for time. So instead of x, f of m equals that zero term 50 times the r number 1.03 raised to the x power. Or I could use the first term, 51.5, times 1.03 raised to the x minus 1 power. Either of those explicit equations will match this data. When I graph it, I adjusted the scale a little bit. I said every 1, 2, 3, 4, 5 boxes is going to be 2. So this is 52, 54, 56, 58, 60, 62, 64, 68, 66, 68, 70. This would be 50, 48, 46, 44, 42, 40. To make the scale, I'm doing 0, 50, 151.5, be over 1, up a little bit on my graph. Over 2, up 5301, would be about halfway there. Up 3 is 54.6. And then the next one is 556.24. Do not draw a line straight through these. These, even if the first part's not curving, you got to understand that these geometrics will eventually curve up. You do not want to draw a straight line through that. That would make it look linear. This is not linear. This is exponential. So no matter how your points look, know that you have that curve look to it. It will be in one of these exponential curves. Okay, the last problem. Continuous for this one, exponential, explicit form, all those things. Alright, the last one is a little tricky because this one has a pool that's 1500 full of water and it's going down by 3%. So this one, instead of using the common ratio as 1.03, I'm going to take that 0.03 away from 100 and use 0.97. So for my time, which is minutes, number of gallons on top, I have the first four terms, 0, 1, 2, 3, 4. My zero term is the number of gallons in the pool right away, 1500, times this, not as 1.03. It's not a percent problem where the money's going up. This is a pool problem where the pool is draining at a geometric pattern, geometric rate. So I'm going to use not R equals 1.03. Since it's going down, I'm not going to add 0.03 to 1 and get 1.03. I'm actually going to take 1 and subtract 0.03. So don't use 1.03. Going down, I'm going to use 0.97, which is just 3 percentage points away from 100. So 0.97, that is my common ratio. So 1500 times 0.97 will make this go down a little bit, which goes down to 1455 times 0.97 again goes down to 1411, and then that times 0.97 again using the recursive pattern, keep timesing, gives me 1369, and that times one more 0.97 gives me 1327. This definitely is explicit. The pool is draining every second. So I'm going to use f of t, for t in minutes, is 1500 times 0.97 raised to the x power. The third word is lines. Lines is the third word. Okay, so again for my graph, the way I made this scale was 1500 here, and then 1, 2, 3, 4, 5. This is 1460, 1470, 1480, 1490, 1500. This would be 1440, 1430, 1420, 1410, 1400. This would be 1390, 1380, 1370, 1360, 1350. So going up and down by tens here. Alright, so to graph this, I would have time on the x-axis in minutes, and on the y-axis I would have number of gallons. So if I graph this, 1, 0, 1500, 1, 1455, which is really a little bit too low. This would be, oh, maybe a little bit lower right there. My next point, 2, 1400 would probably be a little bit higher. 3, 1369. 4, 132793. Notice, do not want to draw a straight line through these exponential geometrics. You want to try to curve your line best you can. No way will this be a straight line. So even though the data you have might be straight, eventually it will curve out. So make sure you do that. This problem is linear exponential using the explicit form. It is continuous. All those things you need to know. Alright, the last two problems you're going to compare. So I'll try to open that up right here. Again, for number 5, you're comparing problem number 1 right here to problem number 3, similarities and differences. How they're similar. They're similar because they're both increasing. They're similar because they both have a zero term. They're similar because you could write an equation for each one of them. They're similar because they give you data to graph. Differences for sure. This linear one is a straight line. This exponential one, curved line. Another difference. This one uses the recursive function. This one uses the explicit function. Another difference. This is adding by 3. This is timesing by a number. Another difference. No exponents in this equation. This equation has exponents. Okay, the next problem. Comparing 1 and 2. And again, similarities. They're both linear. They're both arithmetic. They both have the same rate of change. They're both adding to go up. They both give you data to graph. They both give you functions to use. Differences. The first one's discrete, dots. The second one, continuous, linear. Differences. This one uses the recursive form. This one uses the explicit form. Another difference. This one goes up by 3. This one goes up by 2. There's a similarity. They both have the same y-intercept. Again, similarities, they're the same. They're linear. Differences, discrete, continuous. All right, hopefully you heard those. The fourth word is explicit. Explicit. Okay, the last one. And again, be writing these things down, I'm telling you. So 3 and 4. 3 and 4, the similarities, they're both exponential. Similarities, they both have a common ratio that you're timesing. Similarities, they're both the explicit form. Similarities, they give you the same, or they give you data to graph. Differences, this is a increasing exponential. This one is a decreasing exponential. This one has a common ratio more than 1. This one has a common ratio less than 1. This one has a 0 term, then it's going up. This one has a 0 term, then it's going down. So those are some key differences. But similarities, they're both exponential. They both are timesing. They both use explicit form. Differences, one is increasing exponential, one is decreasing. One has r bigger than 1, one has r smaller than 1. One has 50 going up, one has 1500 as a y-intercept going down. Okay, so make sure you're writing those key similarities and differences. Replay to hear what I said again. And then the fifth and final word is functions. Functions. Good luck.